Hi, I'm David Gagnon, and this is Luke Swanson. We're from the University of Wisconsin-Madison in the United States, and specifically from a group called Field Day. So let me talk a little bit about that. If you're on a computer and you like to stay multimodal, go ahead and take a look at the website while I'm talking. I won't be offended. It's fielddaylab.wisc.edu. So Field Day Lab is both a research laboratory within the Wisconsin Center for Education Research, which I'm told is the largest education research group in the country. But it's also a studio. We make quite a few games. So I'll show you a couple of recent releases. Headlines and High Water is a game about the practices of journalism and how journalistic knowledge is created. Wake is a recent underwater ecology science practices game. So again, this is like how is scientific knowledge created, how are models created and validated, and how are experiments created. Legend of the Lost Emerald was done working with underwater archaeologists, so shipwreck hunters, and trying to figure out how history is made, like how we know what we know about history, and specifically shipwrecks. And Joe Wilder in the Capital Case is also a history game. This is for littler kids, and this is really teaching about archivists and how records are created and corroborated, and narratives are constructed out of physical artifacts. So these are some of the games that we have, but we actually have quite a collection at this point. So as a studio, we're actually joined by our creative director, Sarah Gagnon, who's in back. And we use the phrase often, which is that we're a group of artists making games. And we're making games for the public. So often we get confused with being a private group trying to make money. And instead we're just leaning completely into the idea that games are a proven good way to do learning. And they should be made as a public good to all kids. So we figured out funding models around that we can always give away access to all of our games for free. As a lab, the kind of unique thing about us is that everything we do is at scale, meaning we're really asking the question, what kinds of educational research can do when you have 1 million people creating data sets? What kinds of new experiments can be constructed? So I guess one of the other things to mention there is that across our portfolio of games at this point, we did a kind of a radical thing, I think, within at least our university, is that we knew that universities are horrible at disseminating ideas, and instead we partnered with distributors. So we worked with a company called BrainPop, which has licenses with about 25% of the schools in the country, so quite a bit. And then we also work with our public broadcasting system, PBS Learning Media, it's called. So between those, we get about, it depends on the day, but during the school year, somewhere between 5,000 and 10,000 players every day are playing our games and generating data sets. So that naturally led into, as soon as we started collecting this data and doing research with this data, it naturally led into a question of how do we manage it and what kinds of work can we do with it. So here, insert educational data mining, and learning analytics, and these end up being kind of the frameworks in which we do things. So from a research standpoint, game data is really interesting. And the reason is because games are interesting. They create interesting learning environments. I'm quoting Eric Harpstead, who's also a member of our team who's at Carnegie Mellon. So some of the things that are interesting about games is that they have a goal. We're pursuing some sort of claimed goal that the designer has created and scaffolded, hopefully. So there's a series of goals, but we don't actually know what the player's goal is. So it's one of the first challenges when we're looking at data is to try to figure out what they were trying to do, because obedience and efficiency aren't necessarily what everybody is always questing for. The other thing is that they have amplified input but mediated consequences. Meaning, in games, everything we do has these immediate feedback loops, and we don't see that in other learning environments. And the consequences of it are, well, they're digital and they're mediated, which means, like a game like Plague Inc., killing everybody on the planet isn't a bad thing to do. It's just a way to explore an interesting system. So this creates a really, unique way of learning and interacting with with the choices learners make. The other thing is that they're situated. They're fundamentally based in situated cognition, I would argue. They're perceptually situated, like, I'm looking here obviously at Rock Band, meaning everything about the environment, from sound to visual design, is designed to pull you into the world of music and music production. And it's socially situated in the sense that certainly there are social games, but the learning that's happening in a game like Rock Band, for example, it's really an epistemic frame that it's inviting you into, right? It's really a way of knowing and being and making meaning in the world. And the feedback systems that exist within it are done in the domain of music, right? So this is always where I draw this distinction between gamification and games. Is gamification will give feedback in some arbitrary way using points and stars, but a domain that's different than the actual topic or content, where a game or game-based learning like Rock Band is giving feedback in the language of music. So it's crowd cheering, it's the music continuing, it's the drum beat not dropping out because you missed it. So it's situated. Okay, so this leads us to this interesting question of why open and why are we talking about open game data. So I'm just a firm believer in open and open source. I think it's the world I grew up in. And I'm excited about the idea of sharing and what kind of collaboration comes out of that and what kinds of acceleration come out of that. So when we start looking at what open science is, it unpacks a lot for us. So open science is really a collection of approaches that result in transparency, is really what it comes down to. I think it originally was coming out of the movement to fix the replication crisis, as they call it in psychology, where lots of tenured professors were created based on some research or some idea, and at the end of the day, the data didn't really even show that the science wasn't solid. So we have this idea of pre-registration, which means before we enter into an experiment, we kind of claim what it is we're doing and what we're looking for, what our hypotheses are. Open materials means that if, for games at least, it means that if we build a game and we spend $1 million on building a game, that we can share that game itself so that the next scientist can come along and modify that game and not have to spend $1 million again, right? You can reuse the materials as much as possible. Open data means that the raw data sets that are collected are also shared, so they can be analyzed by a third party. It's not the same person. Open analysis means when I publish a statistic, like I'll be talking about a VR game that we made, and I put some numbers on screen and some bar charts, I can also show you the math that goes with that and the Python code that generated it so that you can code review and see if we cheated in some way. And then open access means the results of all of this then are available to the public. And I get particularly excited about this because often taxpayer dollars are the ones that are paying for everything we're doing. So the idea that we would sell that research back to them kind of makes me ill. So what this means for games is, I think, particularly interesting. At least in the United States, there's probably, I don't know, 2 or 3, a small handful of institutions that can do the kind of research Field Day does, meaning a full-blown studio, data infrastructure, data analysis staff. This requires a team of, for us, almost 20 people. So this is not an easy endeavor to get into. And if you're not at one of those institutions, there's really no way in, right? And this is something that happens to me almost every time I speak at a conference, is graduate students come up afterward and say, I want to get involved. And the answer really at most institutions is, well, you can't. You can make a small game maybe based on your own budget, but for the most part, you're kind of locked out unless you're at an institution that does all of these parts. So what we're really trying to do with open game data is decouple these components. We're trying to say that the game studio can exist separate from distribution. You don't need to have those two. You don't have to have all the data collection analysis, and you don't have to have all the analysis ready to go. And if you have one of those components, we're hoping you can join us and join in at some point. So let's talk a little bit about what open game data is, kind of technically, and then we're going to end with a little bit of some of its uses and ways you can get involved. So I'll hand it to Luke.
Sure. Hi everyone. So my name's Luke Swanson. I'm a graduate student in computer sciences over at UW-Madison. I've been working with Dave and Field Day for the last 3-4 years. So we've heard a bit about what open is and a bit about what games are, and now I'm going to talk a little bit about the data and the technical side of open game data here. So just as a starting point, we've got a website. So for any of you following along from the Field Day website, if you took a minute to check that out, opengamelab.fielddaylab.wisc.edu is sort of our central online presence for all things open game data. The sort of primary use there is that we've got a whole bunch of data sets, event data that we've already collected from, at this point, about 17 different games. We've got a few more that are sort of in the pipeline that should be showing up in the near future. So feel free to check that out as I'm talking about sort of the technical resources that we've got. And so just to sort of introduce that, I just want to talk through a little bit about generally when we go to do sort of research on games and the data from games, what are we thinking about, what are we doing, and how can we help to support that kind of research. So usually step number one is that we're looking to collect raw telemetry data out of our games. So player X started level 1, then they click this button, then they click that button, event by event by event, what were the individual things that happened in a gameplay session. Second step usually is we're looking to extract some sort of features summarizing the gameplay. So rather than this happened and this happened and this happened, the second step is generally, let's figure out probably how many levels did this player complete? How many points did they score? Things of that nature. And from there you get into sort of the science of things, performing analyses, whether that might be traditional statistics. We release 2 versions of a game, and then we're going to figure out, on average, how many levels did players complete across these 2 populations. Let's run a t-test. Figure out if there's a difference in how people play these 2 different versions of the same game. If you're on more of sort of the computer science side of things, maybe you're going to do some machine learning, try to predict how many levels someone will complete. You might just do some data visualization, explore sort of the breadth of player experiences. All of these are types of analysis that we've done at Field Day that we aim to support with open game data. And then the last part, of course, in any scientific endeavor is to report your insights. So maybe at the end you write a paper and your conclusion is that when we included hints when a player fails a level, that led to players completing 15% more levels overall. They persisted longer when we gave them hints to keep them going. I just made that up, but it's sort of a straightforward example of the kinds of analysis you might do in game data research. And as Dave sort of alluded to, sort of traditionally, in order to do this, this kind of research, a lot of times you need to have like every part of that, from building a game all the way through doing the science. Everything kind of has to be in one place in order for anyone to get in. And so part of what we're looking to do with open game data here is to make it easier for people to jump in and out at different parts of this process. Okay, so with that being the process, what do we do to support each of those steps? So on the telemetry side of things, we've developed basically logging clients that can be easily integrated into games as they're being developed. If we've got people in the crowd here who are in the sort of game design, game development side of things, we've got these clients available to basically collect and send out that telemetry data to be stored somewhere. We're always looking to bring in more games as part of open game data. You can log data onto one of our servers, or you can set up your own. For that sort of feature extraction step, let's summarize what individual players were doing. We have a modular data transformation pipeline, with the basic idea being that if you can set up an event filter, an update rule, and a calculation rule to, let's say, figure out how many levels did this player complete, or what was this player's average score across all of their levels. All you need to do is figure out sort of those 3 pieces, and you can create a new feature that can pop out as a summary for each individual player, each individual gameplay session, or populations of players. And you can customize which of those features you want in a data set. And from there, the analysis side of things, we have those shared data sets that I mentioned as part of the Open Game Data website that we release all of our latest data on, I think, the second day of each month. We also have what we're referring to as templates for things like data exploration. I got a brand new data set. I want to just take a look broadly at what players were doing in the past month or the past week, or whatever data set I've got. And also templates that serve as starting points for actual analyses, whether that's traditional stats that we talked about, machine learning, any of those kind of things. And then the last part is insights, right? And that's the sort of final end product of research. And yeah, that's actually just research. So we don't directly have tools to support that. That's the thing that as scientists, we're all trained to do. And the goal here is that the resources we provide in those first 3 steps can help empower people to reach that final point of doing research and having insights to report. So then just to give like a brief overview of what that sort of looks like, we've got sort of 4 different phases here, all supported by automation to make sure that we're continually able to put out new data sets. So everything from game clients, logging and storage of that data, the transform pipeline, and outputs, files on the website, or web APIs for interactive and real-time applications. And then I just wanted to sort of briefly summarize kind of the different technologies that we've integrated here. Exploration templates, finally, use Jupyter Notebooks, another popular data science tool. Use tools that GitHub and Google have built for running those notebooks online for collaborative work on analysis projects. So we've got a number of different technologies that we've kind of brought together to build up this infrastructure. And then lastly, I just wanted to say a couple words on just sort of what that data transform pipeline looks like. That's sort of a big term, and I just wanted to break that down a little bit further so it's clear what we're doing there. So the idea here is to aggregate, like I said, individual events and create some simplified representations of gameplay. So we had a game called Lakeland where players are building farms and trying to build up a farming community. So that one individual player might have a bunch of events that were, I bought a farm. They might have some others that said, all right, when I place my new farm, I put it in a good, fertile spot on my farmland. So we can take those, aggregate them together, and get a feature for that individual player that says, here's a percentage of farms that were placed on fertile soil. And we can think about different levels of granularity of analysis. So sometimes I might actually be interested just in what was a sequence of events. So we've got a stream of events. Sometimes, if we've got a game that supports multiple gameplay sessions by the same player, we might ask, when a player sits down and plays a game in class, how long do they play? So we can aggregate at the level of session, put together a bunch of events, we get a session of gameplay. We might be interested in a player's experience across multiple sessions, or just one session. We aggregate multiple sessions together into a player. And then lastly, if we take a bunch of players, we can put them together and get a population. And so we're able, with Open Game Data, to support feature extraction for any of those levels of granularity. And lastly, a couple of the sort of advanced transforms. There's a couple other ways we can think about aggregation. We have this idea called event detectors. So rather than aggregating events to create simplified features of a whole gameplay session, we can aggregate a bunch of events in order to generate a new calculated event. So things like a player was idle for a while. or a player experienced struggle in the game. It might be something that only becomes apparent when you look at multiple events in sequence, but there's one key moment where you say, here's the marker of when they started to struggle with this level. We also have the notion of higher order features, where instead of aggregating events to make features, we can aggregate features to build features. And sort of an active area of development is figuring out how to integrate machine learning models into our data transformation pipeline. So I'm going to turn it back over to Dave. We'll talk about practically what are some of the analyses that we've done that you can do with the infrastructure that we provide.
Great, so here's the 2-minute version of just some of the things that we've done at least. Here was a recent paper that came out where we used a process called epistemic network analysis to actually compare over time sequences how players did before, like what strategies players used before and after a key event in the game, in this case, dying. Another one would be, we take all of these features and develop taxonomies using things like clustering technologies. So this allows us to look at a group of players and say, are there kinds? Are there certain strategies people use? And out of all the players, how many people use those certain strategies? And we can adjust our game design in response. Another one that we can do, it's also design-centric, is run A/B experiments. And in this paper, we ran 4 different versions of a script exploring the effect that humor and snarkiness, as we called it, in the protagonist had on gameplay engagement for 4th graders. Another one is that we, because of these APIs, can run all these analysis in real time. So the question is, how can we use real-time insights in how people are playing games to support classroom instruction? Obviously, it's challenging for a teacher to look over the shoulders of 30 kids. So is there any way that we can, synthesize a bunch of information into something that they can provide actionable? And the paper here is cited below. Then we get into things like assessment. So using strategies like evidence-centered design, or I guess you can just use educational data mining as well. The question is, can we do things like establish validity of the ability for the game to assess someone's own mental model of a complex system? Another one that we've been playing with is really combining humans and machines together and say, what if we have human beings use qualitative processes to look at gameplay replays, so basically videos or text replays of what someone did in a game, come up with codes, in this case struggle, something they're looking for using their human qualitative mind, and then train machines to be able to detect that in real time. So this is a paper that shows that working out. So here's where we're at from here. We really are looking to build a community around this. We've got several small funding streams that have come in to support this as a new national research infrastructure. So go to the website, download data sets, get involved in that way. We also have a travel grant for anybody that uses any part of open game data and presents on it. There's a Slack community that just got started with maybe 50 members or so internationally that we're inviting you to join into. And then one of the main ways to kind of like just get together and talk is we've been hosting these office hour events where we have someone who's working in game data presenting on a hard problem that they're working on, and then as a community we just kind of help them. And this happens every other week, and you're invited to come and share your projects or just listen in on kind of a master class. So that's it for us. Thank you very much for your time.
Thanks very much. Maybe if we could get the next speaker to come down and set up while we take maybe a couple of questions. If we have time for 1 or 2 questions. So our next speaker is Robin Horst. Any questions for David and Luke while Robin is setting up? Yeah.
Is there a difference between e-learning analytics and game analytics?
Did you ask the difference between learning analytics and game analytics?
Yes, in your case.
Yeah, so I would say game analytics are often focused around just at a high level describing an experience. And most of the tools that are developed to do that are about monetization at the end of the day. When we talk about learning analytics, we're trying to understand what's happening in the mind of the kid, right? The person playing. Like, what can we derive, what can we infer about their thinking processes based on the way they're interacting with a complex system? And that requires an entirely different process for analysis and visualization and tools generally.
ready to go.